The Ethernet network is a new home for video distribution, and with SDVoE technology matching the performance of a matrix switch, it's important to have clarity on how a network switch achieves this. This course will introduce you to multicasting, and more importantly, how Internet Group Management Protocol, or IGMP, is used to manage multicast traffic across a network.
We now know that networks use packet switching as the method of getting data from one host to another, and matrix switches use older circuit switching technology to do the same thing. We also know that packet switching is far more reliable, more flexible, and more scalable than its circuit switching counterpart. And we hear the term multicasting used time and time again when describing video over IP. But what does multicasting actually mean? Googling multicasting isn't necessarily always very helpful.
In computer networking, multicast is group communication where data transmission is addressed to a group of destination computers simultaneously. Multicast can be one-to-many or many-to-many distribution. Multicast should not be confused with physical layer point-to-multipoint communication.
Any wiser? No, I didn't think so. I tell you what, let's make it simple. Multicasting is how bandwidth is managed when a single source needs to communicate with multiple destinations, and it lives with a couple of friends called unicasting and broadcasting. Each one has a role to play in the transportation of data packets. In fact, it's fair to say that without these three chaps, there wouldn't be any moving of data packets at all. Let's start with unicasting. This is by far and away the most common form of data packet movement used. Unicasting is used when a single host needs to communicate to another single host. Whether you're grabbing the latest news updates or sending a message to somebody, unicasting is used. Think of unicasting as a phone call from one person to another. Broadcasting is when a single host needs to communicate to every other host on the same network, making it a pretty inefficient method of moving data packets. You can think of broadcasting as a public address system. Everyone is going to hear the message whether they want to or not. Imagine if you sent all your video packets to every single host on the network, regardless of whether they wanted them or not. Within seconds, the network switch would hit its bandwidth limits and, well, stop working. Upon receiving a multicast packet to which no one is subscribed, many network switches will broadcast that packet, and this is bad for video distribution. This problem can be easily avoided by finding the setting which allows you to drop or block unregistered multicast packets. There are also free software tools available which allow you to see other broadcast data packets on the network, and this is really useful information when troubleshooting slow networks. Multicasting is the network function used to send large amounts of data packets, like video, only to the hosts which request them. Multicasting is similar to a radio station, in that it allows you to select what you want to listen to and when you want to listen to it. So, while that station is always available, you only get to hear it if you tune into it. Multicasting in the world of Ethernet prevents wasted network bandwidth by only streaming content to the receivers which request it. So, how does multicasting work? We can see the transmitters and receivers are all connected to a 10 gigabit Ethernet switch, along with the SDVoE controller. The transmitters are connected to the sources, the receivers are connected to the displays, and the transmitters are constantly receiving video and audio from the sources. And now, multicasting steps in. Inside the Ethernet switch is a Layer 3 protocol called IGMP, or Internet Group Management Protocol, And it's this set of rules which is used for multicasting. IGMP has two key features: querying and snooping. Once the SDVoE transmitter has identified the HDMI video and the HDMI audio connected to it, it will inform the IGMP querier inside the switch that it has these ready to go. The querier will then assign individual data streams for each one, and the SDVoE controller will give each stream a unique multicast IP address. These IP addresses begin at 224.0.0.0 and end at 239.255.255.255, and you'll never see these addresses used for physical hosts, because they are reserved for multicast addressing only. So, now we have multiple independent streams, each with their own multicast IP addresses, ready to be sent if they are called upon. Remember, these streams are not actually being sent across the network yet. Now let's turn our attention to the receivers. The SDVoE controller will tell a receiver to connect to one or more of the streams available from a transmitter. To make this happen, IGMP snooping is used. The receiver will inform IGMP snooping inside the switch that it needs to receive the HDMI video and HDMI audio streams from transmitter 1. IGMP snooping will then find out from the IGMP querier if that stream is still available, and if it is, the stream will then be sent from the transmitter to the receiver, and it's at this point the network bandwidth is being used to stream the content. Now we have a reliable mechanism for sending video streams across a network, only if they're required. Adding more transmitters and receivers to the network switch simply means this process is repeated each time. Multiple receivers can request streams from any transmitter, and because the video and audio is broken out into separate data streams, a single receiver can actually receive video from one transmitter and audio from another. In the case of the multi-view application, a single receiver is actually receiving multiple video streams from multiple transmitters and placing them all on a single display. And this is all made possible with multicasting. Multicasting is extremely efficient, because if a stream is no longer required, it gets disconnected without disrupting other streams which are still being used. By disconnecting unwanted streams, network bandwidth efficiency is being maintained. However, you still need to consider your network topology design to ensure that you have enough bandwidth for your video content, especially when using the multi-view application. And you can learn more about that in the Introduction to Network Design course here on the SDVoE Academy.